All right, here we go. Video notes on relations, domain, and range. Let's talk about what a relation is. Basically, a relation is a set of ordered pairs. And an ordered pair is basically some coordinates, like 2, 9, 1, 3. That's an example. Those are examples of ordered pairs. Relations can be expressed in 4 different ways. They are ordered pairs, graphs, tables, or mapping. Okay, so let's take a look at each way. First way here is we're going to look at ordered pairs. So here we have a whole bunch of ordered pairs over here, aka coordinates. So let's start off with listing them out here. The easy one here, we have 0, 0 in the middle, also known as the origin. Here we have this point, and so to calculate that ordered pair, we count on the x-axis first. -1, -2, -3, -4, -5. -5 on the x. And then we count up 1, +1 on the y. This ordered pair, -1, -2, -3, -2. Okay, so here's all our ordered pairs. There's 1, 2, 3, 4, 5, 6, 7 coordinates. There's 1, 2, 3, 4, 5, 6, 7 coordinates. Okay? Also, if I ever make a mistake on a video, please feel free to mention it to me. We all make mistakes. Remember, it's okay to make mistakes, as long as we learn from them. So let's go ahead now and look at a table. So obviously we have a graph. This represents a relation. We have ordered pairs, represents a relation. Now let's go ahead and put these points in our table. So you should have them written down. So our origin. Then I'm not going to worry about order right now. I'm just going to go ahead and put them down. -5, 1, -3, -2, -2, -5. Okay, and so there's your table. That's another way to represent a relation. Okay, fourth way, mapping. So we put our x coordinates in the first oval, our y coordinates in our second oval, and then we connect them with an arrow. Okay, I put my x coordinates over here. I put my y coordinates over here, and notice these two y coordinates are the same. And so you don't have to put the number in here both times. So we actually only need one of the -2's. And you'll see why in a minute. So 0 goes with 0, so I'm going to draw an arrow from 0 to 0. -5 goes with 1. -3 goes with -2, so I'm going to draw a line here. -2 goes with -5. 5 goes with -2. 2 goes with 2. And 4 goes with 6. And that's how you do a mapping. Okay, let's talk about domain and range. I know that you've had this before in Algebra 1, but we need to review. Domain is the set of first coordinates in a relation. That would be all the x values. Range is the set of second coordinates in a relation, which is all the y values. So now that we've talked about relations, there's a special type of relation that we deal with, and it is called a function. The function is a relation in which none of the first coordinates repeat. In other words, all the x values are different. If the x values repeat, then it's just a relation and only a relation. If the x values do not repeat, we have a function. So take a look at number 2. It says state the domain and range, then determine whether or not the relation is a function. So Let's do number 2 together, and you can do number 3. So looking for the domain, so back up here, the set of the first coordinates in a relation, all the x values. So just recall that the first number represents your x value, the second number represents your y value. So if I'm going to list all my x values out, and I'm going to use set notation, so I'm going to use a bracket here. So 2, 3, 6, -1. And there's our set for our domain. Okay, range. The set of second coordinates in a relation, all the y values. So again, this time just be careful that you get the second number each time using set notation. 4, 5, 5 again. We do not need to write it again. It repeats, so we do not need to write it again. And 3. Okay, is it a function? Let's see. All x values are different. Looking at our x values, they're all different. So yes. Okay, so you try number 3 on your own. Tomorrow I will check your number 3. When you get your video notes out, I will be checking for number 3 that you have it done. Okay, let's take a look at number 4. Express the relation shown in ordered pairs. Then state the domain and range. Is it a function? Okay, so let's write the ordered pairs here. So let's start off with, remember our first oval, these are our x values. Our second oval is our y values. So starting off with 2. So let's go ahead and write these over here. So 2, follow the line. Let's go ahead and start with this one up on top. 2 goes with 12. Okay? 2, let's follow the other line, goes with -3. Okay? Okay, we're done with 2. 1, follow the line, 1 goes with 5. Okay, done with that one. 0 goes with 0. Remember what that's called? Correct, the origin. -1 goes with 5. Okay? Let's write the domain and range. Okay, I went ahead and listed out my domain, all my x values. Notice I had a number repeat, so I did not have to write both of them. Looking at a range, I wrote all my y values. Notice I had a repeating one. I did not have to write 5 twice. Okay, so but you can. It's just not necessary. Is it a function? We got a repeating x value, so this is not a function, so no. Okay, let's take a look at these. We're looking at a domain and range of this graph. Now this graph is a continuous graph, so we're going to be writing our domain and range a little bit differently. Back over here, these are individual points, and if we were to plot them, there'd be 1, 2, 3, 4 points. This is called discrete data. Okay, discrete. Okay, because there's just 4 of them. We're not connecting the points. Nothing tells us to connect the points. There's just 4 points. On the front page, this is discrete data because they're individual points. All right, but here we don't have individual points. Okay, there's an infinite number of points on this line or ray, and they're connected. So we call this continuous. Okay, so if you'll recall, when doing a domain of this type of graph, we'll start off by doing this in inequality notation. Okay, so inequality notation says, hey, domain, remember our x values? So domain, we're going to start with go from the left to the right. So the furthest left point, the x-coordinate is -1, -2, -3. So we're starting off at -3. Okay, it's a closed dot, so my x values are going to be bigger than -3 or equal to -3. Notice how as we go this direction on the graph, x is getting bigger. So -3 is going to be less than or equal to x. Okay? And if I read it the other way, x is greater than or equal to -3. So the x-coordinates, okay, on the graph is going to be greater than or equal to -3. Not less than. Less than would be over here. Okay? And how far is it going to go to the right? There's an arrow. That means it's going to go infinitely to the right. Infinitely to the right. And x is going to be less than infinity. You can never equal infinity, so you never have an equal sign. Never have an equal sign when you have an infinity. Okay? Range, remember, are your y's. So you got to think up and down, not left and right. So domain, you're thinking left and right. Range, you're thinking up and down. So starting from the lowest, well, again, here we are. It's going down infinitely. Okay, then you're less than, then you're y, and it goes up to, if I go over to the y-axis, it's going up to 2, and it's a closed dot. So the y-coordinates are going to be from, made a mistake. Rusty, it's been a summer. Anybody know what the mistake is? Should I correct it, or should I wait for you guys to tell me what it needs to be? Who could be the person that walks in the class and tells me what the error is in this problem? I'm sure you all know what it is. It's an easy error. I hate to leave it there without correcting it, though. So I'm going to go ahead and leave it. There's something wrong with this problem. Let's see who can walk into class and tell me what's going on. What's wrong? What's the mistake? And we'll correct it in class. Okay, try 5 and 6 on your own. And 6 and 7. And see how you do. We'll see you tomorrow. And I will be checking these problems to see if you have them done. Thank you. Have a good night.